Hey mathematicians, we're back with a new lesson. This one's going to be a little weird. It's going to be a very new, very brand new concept. I know that solving systems of equations in 3 variables was new. This is newer. The math is not that hard. Understanding what you're doing because it's completely new is going to be the part that's a little tough for you today. But it's okay. I believe in all of you. And we're going to go ahead and get started. So a matrix is it's a set of numbers arranged in rows and columns and the goal here is to have a rectangular shape. For example, it could be a square, it could be a rectangle. We might have the matrix 3, -1, 0, 4, and it's just 4 numbers arranged in 2 columns and 2 rows. And that's it. The numbers might come from somewhere. We don't know yet. We don't know where they come from. That's not the goal today. We've got 2 rows and 2 columns. A different one, let's just make another one up. 4, -5, 5, 0, 1, 9 has 2 rows, 3 columns. The number of rows and columns matter because those are the dimensions. So that would be the number of rows and then the number of columns. If I spell that right. There we go. And we have to do rows first. That's very important. Rows have to be done first. So this one, like I said, was a 2 by 2. This one was a 2 by 3. It's all about rows first, columns second. When we're multiplying matrices especially, it's going to be super important. So an element is an individual number named by row and column. So let's call this one matrix A and this one matrix B. And so what we do is we have A to 1, which is the second row, first column, which means it is 0. And let's say we wanted to do B to 2, be second row, second column, which leads us to 1. So they might ask you about an individual element. This notation with these subnotes, that's what that's all about. It's about finding one number inside a matrix. Scalars are numbers on the outside of matrices. And the goal of the scalar is to multiply it by multiplying every number inside the matrix. Every number inside the matrix by the scalar. So whatever number is on the outside of a matrix, we would multiply every number inside the matrix by that number. We're going to have examples of that here in a minute. I just wanted you to have the definitions before we went into this lesson. So matrices are these things that we can actually add and subtract. We can actually combine the elements in the different matrices And the goal, the easiest way to do this, the right way to do this, is to add each individual element. So A gets added to E, B gets added to F, C gets added to G, and D gets added to H. And then when it's all over, you have a new matrix made of those sums. So you're going to notice right away, this only works if they're the same dimensions. And this is a 2 by 2. Here we have a 2 by 1, 2 rows, 1 column. This is not possible. We cannot do this. Can't do it. Not going to happen. I can't just add the 3 and 2 and pick which column I add it to, because there's no rule for that. We can't add these matrices together. But these two we can. So what we're going to do is we're going to have a new matrix, same size, 3 by 2. We're going to do negative 2 plus 1, which is negative 1. 1 plus negative 4, which is negative 3. 0 plus negative 2, which is negative 2. 3 plus 9, which is 12. 7 plus 1, which is 8. 6 plus 5, which is 11. Again, if you're like, whoa, what did he do? I added the numbers that were in the same spot. Negative 2 plus 1 is negative 1. And so on. I did that with each location. And now we have a new matrix for our answer. Easy enough. When we are multiplying by a scalar, it's like distributing. It's like multiplying every single thing inside parentheses. Just these parentheses are a little more square. Everything in there is going to get multiplied by this number. You don't have to draw that, but that's just, it's like the claw, but the claw just got, lobster pincery. So 3 times 0, it's got to be the same dimensions again. 3 times 0 is 0. 3 times 2 is 6. 3 times negative 7 is negative 21. 3 times negative 1 is negative 3. 3 times 6 is 18. And 3 times 4 is 12. And we're going to do the same thing again, but this time with negative 2. Negative 2 times 1 is, negative 2. Negative 2 times 0 is 0. Negative 2 times 3 is negative 6. And negative 2 times negative 5 is 10. That's all there is to the scalar multiplication. Now, we're probably going to do some problems where we do the scalar multiplication and then addition. But before we do that, I want you guys to check yourselves. The problems that you're doing, I want you to try these. And then when I come back, we'll have the answers. So go ahead and pause, try these on your paper or on your notebook if you're at home, and we'll come back and check yourself. Okay, so this one's a little different. It was a subtraction problem. We're going to do negative 6 minus 3, which is negative 9. 2 minus 0, which is 2. Negative 1 minus 7, which is negative 8. Negative 5 minus negative 1, that's negative 5 plus 1, negative 4. And on this one, we're going to multiply every single number by negative 3. 3, negative 9, 6, negative 12, negative 6, negative 27, 18, and 0. So just a few of the rules and properties. If I have parentheses where I'm adding 3 different matrices, if I order A to B first, or if I add A to B first, or I add B to C first, and then I add A and B first, then I add C, doesn't matter. It should get the same final answer. The order that I add 2 matrices in doesn't matter. If I have a scalar multiplied times 2 matrices, I can distribute it, and it would still have the same answer. If I have it multiplied times a subtraction problem instead. Subtraction is just negative addition. Same rule. That's what those mean. So let's do a multi-step problem. We've got a last month matrix. Let's call that matrix L. And it had 42 dogs, 33 cats, 56 dogs, 21 cats. And we have a this month matrix, which is 36 dogs, 51 cats, 48 dogs, 37 cats. So on both of these, store 2 is the bottom row, store 1 is the top row. And then the left column is dogs, the right column is cats. Remember I said sometimes it would be organized in a way that makes sense for some kind of situation? This is one of those situations. So if I wanted the dogs from store 2, I could go down to 56. And I would know that that was how many dogs store 2 sold last month. I'm going to take those labels off for now. Don't need them for the next part of the problem. And I've just filled this in. It looks like the problem actually wanted this in 4 different 1x2 matrices. So we're going to do it that way instead. Oh, nope. I said that wrong, and I don't want to edit the video. This is apparently matrix A. This is apparently matrix B. So we want to find the average monthly sales by doing 1/2 times the addition problem between the 2 matrices. So that would be 1/2 times the addition of 42, 33, 56, 21. And 36, 51. 48, 37. And we're going to take a second, and I'm going to use my calculator to add all those. So I added those numbers. I got 78, 84, 104, and I believe 58. Let's see if I can get that going again. Okay. And now I'm multiplying all those numbers by 1/2. So half of 78 is 39. Okay, and half of 84 is 42. And then half of 104 is 52. And half of 58 is 29. So the average between the 2 months for store 1 was 39 dogs, 42 cats. For store 2, it was 52 dogs, 29 cats. And finally, we have something really big and messy looking called a matrix equation. But really all we have to do is simplify everything on the left side and then compare it to the elements on the right side to solve. Easier said than done, but we'll go ahead and we will deal with the parentheses first. So on the right side, we're going to have 4 times... All right, 3x plus 1 is 3x plus 1. 1 plus -3 is -2. 4 times, getting ahead of myself. 0 plus 2 is 2. And then we have 6 minus 2y. And this matrix just carries down. We don't need it yet. We're going to multiply everything inside by 4. So I've got 4 times 3x plus 1 is 12x plus 4. Okay. 4 times -2 is -8. 4 times 2 is 8. And 4 times 6 minus 2y is 24 minus 8y. That is equal to -8, -8, 8, and 0. And you can see a couple of things line up. Negative 8 and negative 8 line up. 8 and 8 line up. And this should be, if you're solving one of these, you should double check that, because if that doesn't match up, if the stuff without the variables doesn't match up, you did something wrong and you got to go back. The good news is, the way this thing works out, we now know that 12x plus 4 equals negative 8. And we know 24 minus 8y equals 0. So we're going to solve those equations. Minus 4, 12x equals negative 12. And divide by 12, x equals negative 1. That's our first variable. Whoops, did that in the wrong color, so we'll just switch over. Subtract 24. Negative 8y equals negative 24. Divide by negative 8, y equals positive 3. And that is where we wrap up that problem. Again, the goal was simplify, simplify, simplify. And then once we had everything simplified, set up our equations, where we knew 12x plus 4 had to equal negative 8. 24 minus 8y had to equal 0. One more. I would love for you to try it first. I would love for you to pause it and try it. And if you get stuck, play again. I'm going to work it out here in about 10 seconds. So if you want to pause, that would be great. Okay, I lied. It was 5 seconds. Couldn't wait. We're going to do subtraction first. This negative 2 is going to come down. And we're going to have 3 minus 1 is 2. We're going to have minus negative, which is going to be negative 2 plus 6. Negative 2x plus 6, excuse me. 1 minus negative 5, so 1 plus 5y. And 7 minus 4 is 3. Negative 2 times those numbers is negative 4. 4x minus 12. Negative 2 minus 10y. And negative 6. So if I am checking some stuff, looks to me like negative 4's match, negative 6's match, which means I'm ready to match up my equations and solve. 4x minus 12 equals 12. And negative 2 minus 10y equals 8. Add 12 to both sides. 4x, whoops, how did I do that? 4x equals 24. Divide by 4, and x equals 6. Add 2, negative 10y equals 10. Divide by negative 10, y equals negative 1. And that's how you do it. You have an assignment on this. I look forward to all of your questions. The math isn't hard, but conceptually it's weird. So I hope you ask whatever questions you need to. And I'll see you again in my next video.